Hey, I'm running through homework answers because I'm not going to be in class on Wednesday. So I'm just doing questions 1 and 2 part A from the homework assignment that's online. To start off with, number 1A, we're looking at 3 points on indifference curve 1, which is this indifference curve that is closest to the origin. Remember, all these bundles that lie on indifference curve 1 give the consumer the same utility. So when we're picking bundles that represent possibilities for this consumer, all the bundles we choose that are on I1 have to give the consumer the same utility. So we don't have a function that gives them utility, but we do know that this type of good, or these types of goods, are imperfect substitutes with each other. We know that because of the curve structure of the indifference curve. So we're talking about goods that the more the consumer consumes, the less the consumer values each of the goods after the first one. So there's some diminishing utility, in other words, that the consumer faces. So let's start off here by saying that one bundle the consumer could have on indifference curve 1 is 3 pancakes and 3 waffles. And then we could slide down here and say we could give them more pancakes and fewer waffles and keep them at the same utility. Perhaps that'd be 5 pancakes and 2 waffles. The other thing we could do is say that they are going to have fewer pancakes and more waffles. Right? Maybe they have 2 pancakes and 5 waffles. Whatever we choose, though, it's important to understand that those bundles all offer the same utility. The consumer is indifferent to all those bundles. Second part, or question 1, part B. Pick a point on I2 and plot it. Why is this bundle on I2 preferred to the bundles you plotted on I1? Well, any bundle on I2 is going to be preferred to I1, and that's because all the bundles on I2 offer more utility than the bundles on I1 do. So a really easy way to think about this: let's offer this consumer the same amount of waffles and more pancakes. Let's say 3 waffles and 5 pancakes, compared to the point where they've got 3 pancakes and 3 waffles. Given this world that we've created here, more is better for these consumers, and this point here where they've got 5 pancakes and 3 waffles is definitely preferred to when they have 3 pancakes and 3 waffles. Now, finally, why can't these indifference curves cross each other? And if I'm drawing indifference curves, one thing that can't happen is indifference curves can't cross. That's a no-no. It's a no-no because it violates what's called the single crossing property. All the bundles on this indifference curve need to offer different utility, either more or less, compared to this indifference curve right there. Now, the shallower indifference curve, for bundles in which the consumer has fewer than X0 goods and more than Y0 goods, the shallower set of the bundles on the shallower indifference curve are less preferred than the bundles that are on the steeper indifference curve. But once we get past X0, Y0, all of a sudden this consumer would like to have more bundles on the shallower indifference curve than the steeper indifference curve. And that doesn't make sense. It has to be that for all the bundles along an indifference curve, they offer the same level of utility. Well, for bundles less than X0 and more than Y0, the consumer evidently prefers the steeper indifference curve, meaning they have more utility from those goods compared to the shallower one. But past X0 less than Y0, the opposite is true. And that doesn't make any sense. That would violate a constraint of rationality that we think consumers adhere to most of the time. So moving on to number 2. I just want to do 2 part A, and then in the very near future we'll do parts B and C. But we're just trying to calculate utility levels with these 3 different utility functions. So the first utility function we have is a Cobb-Douglas, right? Imperfect substitutes. The second one is perfect substitutes. And then the third one, which I'll work with in a little bit, is perfect complements. So for the imperfect substitutes Cobb-Douglas utility function, utility is the square root of 5 times 5, or 5 for that consumer. Then utility changes, it increases, but at a decreasing rate as I give this consumer more X or more Y. So what we're doing is holding the amount of Y constant for the consumer and increasing the amount of X, and what we see is that utility increases to radical 50. Now, radical 50 is not twice 5 or radical 25. Radical 50 is less than twice radical 25, which means that the doubling of X does not double utility in this world that we are looking at here with imperfect substitutes. And that will not be the case here. So here I have perfect substitute utility function, and when the consumer has 5 units of X and 5 units of Y, utility is 25. And then when the amount of X that the consumer has doubles, utility also changes by a commensurate amount. So, right, the utility that the consumer gets from X changes by a commensurate amount. So previously the consumer had 15 units of utility from X and 10 units of utility from Y, and now they have double the amount of X, or 30 units of utility from X, and still only 10 units from Y. So the doubling of X for the consumer increases utility from consuming X by a factor of 2. And that's not the case over here in imperfect substitutes. For this world right here, we can graphically display the indifference curves that this consumer might be on. Right, again, they start off here at a utility of 25, which corresponds to having a bundle of 5 and 5, or they could have 8 1/3 units of X, or 12 1/2 units of Y, to get to that utility level of 25. And so the indifference curve that corresponds to the first level of utility that we calculated there for this perfect substitute consumer is this line here that I've labeled I sub 25. Now as I move on to the second utility function, or the second indifference curve rather, I've given this consumer 10 units of X and 5 units of Y, and I've gotten them to a utility of 40. And notice here, that corresponds to 13 1/3 units of X, or 20 units of Y, right? And then that indifference curve is going to lie on that line. It's just a straight line that corresponds to all the different bundles that the consumer could have at utility equal to 40. Then the final indifference curve that I'm looking at here, the final utility function rather that I'm looking at here, is perfect complements. Right, and this is that weird argument function where I'm looking at the minimum of the two numbers that appear in the parentheses. So if this consumer has 5 units of X and 5 units of Y, utility is going to be the minimum of 1, which is the product of 0.2 and 5, or 5. So the utility there when they have 5 units of X and 5 units of Y is 1. Utility when they have 10 units of X and 5 units of Y increases to 2. right? And what's going on here is this consumer likes to consume these two goods in a 5-to-1 ratio. 5x per 1y increases their utility here. So you can imagine if this consumer only had 5 units of x and 1 unit of y, they would get to a utility of 1. But they've got, to start off with, they've got 5 units of x and 5 units of y, and so they get to a utility of 1, but they've got 4 units of y that aren't being used here at all because they go unpaired. Now, I provide the consumer with more x, but not enough x so that the remaining 3 units of y can get paired in this ratio for the consumer. They always want 5x per y, whether it's coffee per cream or wine per cheese or whatever the combination is. Just increasing x by 5 doesn't allow for them to pair this. So what we're kind of saying here is that the indifference curves for this consumer, they're always looking like 90-degree angles. The indifference curves here are always in that 5-to-1 ratio. So if I want to get this consumer to utility of 1, which corresponds to this indifference curve 1 that I've drawn here, I need to give them 5 units of x and 1 unit of y. As it is, we start off with 5 and 5, which still provides the same utility as 5 and 1. Now, if I double the amount of x from where we started, I'm still not pairing 3 units of y for that consumer, right? The minimum amount of x and y that I need to get to utility of 2 is 10 units of x and 2 units of y. The 5 units of y, that means 3 units are going unpaired or unused.